Hi friends, in this video we will discuss about internal rate of return, and we will also try to appreciate the difference between net present value and internal rate of return. See, the internal rate of return is the discount rate that makes the net present value of an investment equal to zero. In other words, it is the rate at which the cash inflows from an investment equal the cash outflows, taking into account the time value of money. So here, what we are doing, here we are considering cash flows. There is one cash outflow and there are three cash inflows. And discount rate that we are considering is 15%. Now what we are doing here, so let us run this cell. So 197, this 197 is nothing but net present value. At the rate of 15%, net present value is coming 197, which means this investment is viable. Had we got NPV 0 or negative, we would have said that this investment is not viable, not making any sense, not making money. So this is all about an NPV. We try to determine an investment's viability by calculating net present value. That's it. But when it comes to internal rate of return, things will be different. When we calculate internal rate of return, we will try to find out when or at which rate our NPV is becoming zero. Assuming that, we will take the same example. Let us bring in this cell and this as well. Let us write here. Now, at the rate of 15%, we are getting 197. That is NPV, but we have to make it zero. What we will do? Okay, let us increase it little, 18. Now, how much it is? 91. Let us increase it further, 19%. It is becoming 58. Maybe 195, 41. Likewise, see, it is going towards zero, but finding the exact discount rate which will make it zero will be difficult. So what we will do is we will try to get that rate which will give NPV equal to zero by using a method called Newton. See, this is available in SciPy library. So we'll say from SciPy.optimize import Newton. We have already imported this method and we will make use of that method. Now how we'll go about it? Let me remove this. Okay, let that be there. Here, it is already written here. Let me remove these empty cells. Okay, so what we are doing here, we have defined one function. This function is going to take a rate and it calculates NPV and it returns NPV. There is another method, that is Newton method, which we imported. This Newton method will take two parameters. One parameter will be this function and the other will be one initial rate that we can give. What it does is this method is going to invoke this method with this particular rate and check whether it is getting zero NPV or not. If it is not getting, again it will try with some other rate. It will keep doing that until it gets NPV as zero. So let us run this. So we will run This is the function, and this function is going to get invoked by this Newton method. And when we run that, we get 20.8%. Look, this is what we are getting. So this is the rate at which, if we consider our discount rate, then our NP will become 0. Is it going to happen like that? Let us check that. So here what we are doing, we are calculating, and here see, final rate is what? 20.8. So we are plugging in that final rate over here. It is same list comprehension. It is calculating NPV, and we will run this, and indeed we are getting 0. That means if we apply 20.8%, our NPV will be 0. And what is this 20.8? This is what is internal rate of return. Let us repeat. Internal rate of return is that discount rate which makes our NPV 0, which means this is the rate which will make our cash outflows equal to cash inflows, right? So we can now, having used this Newton method, got this, and we have plugged in and it is working well. Now what we can do is we can go to Excel sheet and see how internal rate of return is calculated in Excel. So we will go to Excel now. Let us switch to Excel. Here we are. Same figures, same amount. We have to write IRR, and then what it is expecting, values, and guess the discount rate is optional. We will not give. We'll say press enter. We are getting 20.8. Okay. Okay. Here precision is only 2. That is fine. So what we are getting, what we got through Newton, the same percentage we are getting. Correct? Let us switch to Jupyter Notebook again. Here we come. So now we used Newton method. We saw the result in Excel sheet, and we have also understood the difference between net present value and IRR, that is internal rate of return. Now, assuming that we don't have this method, Newton method, and suppose we don't want to use Newton method, but still we want to find out what is that rate, what is the discount rate which is going to make our NPV 0, then what we will do? See, okay, so discount list is an empty list, NPV list is an empty list at the beginning. We are considering this, and here we are calculating and putting the, this is NPV amount into NPV list, and the rate which we are considering, we are putting into discount list. Okay, and there is one if condition here. So what we are doing here is we are saying when this S is nothing but NPV, when our NPV is becoming less than 0.01, please exit from this loop. Okay, let us do that. Here we go. So that has already happened, and let us see what is there in discount list and NPV list. We can also create a data frame and see how things are looking. So what we will do, we are creating a data frame. This is discount list and this is NPV list. So let us see that. So what happens when we are considering 10% discount? This is the NPV. When we are considering 10.1%, so see here it is 392. Likewise, it is coming down, right? Our NPV is coming down and our discount rate is going up like this. And at one point in time, we are exiting from the loop. When? When the NPV is becoming less than 0.01. See, this amount is less than 0.01, just here. And at that time, we are exiting and our discount rate is 20.9, but we will consider this one. We will consider this one. We will not consider this one because here the value is becoming less than 0. We are interested in 0, and this is slightly more than 0. So we will stay with this. We are not getting into so much of precision. It is not needed. Okay. So we have already got this percentage, right? This is the percentage and this is the amount. So can we calculate and see whether we are getting this amount or not? Yes, we can do that. So where is our formula? Okay, this is what it is, right? So let us bring this here and calculate and see whether it is matching with that or not. Okay, so what is that rate? The rate is going to be 208, right? Like, let us write this decimal. Yeah. So when we run this, we should get this value. And that value is what? That is our net present value. Have we got 0? No, but very close to 0. And we are stopping it at it. Okay. So what we have got? Look, 0.0466. 0.0466. So we will think that we have got a rate, discount rate, which is giving us net present value 0. Of course, not 0, it is close to 0, but that is perfectly fine. Okay, so this is how we can calculate if we are not using Newton method. This is a beautiful method which we can use and we can get this discount rates, right? It is giving us very nicely, quickly. But we have also learned in the absence of such method how we can calculate. And at the end, what we are doing is we are just whatever calculation has been done, right? We are using those data and drawing this graph. So what we have done, see, we are starting from 10% and we are just increasing that percentage. That is discount. This is x-axis is discount and y-axis is net present value. See, net present value will be starting from, just see, let us see here. It starts from 396 and keeps coming down, down, down and goes till this 0.04, right? So here, starting from 396, it keeps going down and comes here. At this point in time, it is 0.046, right? And after that also you are seeing that blue line, right? That is nothing but this is about that minus 3.09. It's coming here. So at this point, look, this is 0, right? This is 0. This black line, this is 0. So this is net present value. This NPV is 0 at this point in time. Where it is intersecting our this one, blue one, it is intersecting here and we have this red line. This red line is about discount. So our red line and blue line is intersecting over here, right? So we have to see where is our net present value as 0. This is the 0, 0 here, okay? So it has come down right from 396 and it is merging, this blue line is merging with this black line and this red line. This vertical red line is all about our discount rate, and this black is nothing but zero. So it is merging here. This is a, a pictorial representation of what we did in this piece of program. So let us summarize the entire thing. In this video, we discussed what is internal rate of return. So what is internal rate of return? Internal rate of return is such rate which, when applied to our calculation to find out NPV, it makes NPV 0. So while doing NPV calculation, the target would be to make NPV 0. There will be a particular rate at which NPV will become 0, and that rate is called internal rate of return. And this rate is going to make our cash inflows equal to cash outflows. And that is precisely when it will become 0, right? It will see cash in, see, we are summing it up. There will be calculation of cash outflows and then cash inflows. Of course, time value of money will be considered, and that is built into this formula. And when cash outflows will be equal to cash inflows, it will be 0. So that NPV will become 0. And then we will call such rate, such discount rate, as internal rate of return. Thanks for watching, and I will see you in the next video.